Let's compare initial rate, instantaneous rate, and the average rate. In order to do that, again, we're going to do the same thing. Molarity versus time. And in this case, what you do, again, the reactant's going to decay in the case like NO2 decay. And slowly it will be losing and losing and losing, and you're going to see that trend. Right now, if I do slope for the first point, the initial point, I will get a slope like that, right? And the tangent, the tan theta, or the slope would be the initial rate. In a reaction, initial rate is the highest you're going to get, and we can write it tan theta rise over run, and that's a simple way to look at it, how you get the initial rate. And that would be molarity divided by time, in our case molarity divided by seconds of the reactant, right? And that's an important one, initial rate, and that's the highest you're going to get in a tabulated form or in the graph. Now, any other data point in the graph, I can draw like in this fashion, right? So if I do that, what you get is the instantaneous rate. So we can just find any point, either we can calculate or we can do the graph, draw it, the instantaneous rate. So that's also a tan theta, the red one. And then that's also rise over run. That would be molarity divided by seconds, right? So it's the same thing, but this is at any point that you select, instantaneous rate. Now, instantaneous rates would be lower than the initial rate. Now, we also can get the two endpoints. In this case, no, we'll take the yellow triangle. So that's actually showing, you see, the slope is getting smaller and smaller and smaller. We know reactants are decaying and losing, so your rate will be losing, getting smaller and smaller. But we also can do one thing. What we can do, we can get the other type of rate, which is this bigger triangle, and covering the starting point to the end point. And that is called the average rate. So in the average rate, what you're actually taking, the whole change, the complete molarity change from the beginning to the end divided by the total time. So this time is actually final time minus the initial time, which is 0 seconds, right? So you can plug it. Now also you can notice the average rate, when we write it for the whole time, it's not really indicating the actual rate of the reaction, right? Because you see the actual rate went like that in a parabolic shape, but our average rate indicated very nicely in a tan theta slope. So that's the difference.